Good day. In this lesson, we're going to be looking at the application of Newton's second law, specifically with a block on hill, and we've got a two-body system with some tensions. So it says ball X of mass 3 is attached to a trolley Y, of mass 4 kgs by a light string which passes over a frictionless pulley. So basically, do you agree that it doesn't matter if this is 3 kgs, the tension in that part of the string is the same as the tension in this part of the string, otherwise they wouldn't be nice and stiff, the string. They'd be like wobbly bits. Okay, then it says initially trolley is at rest. So we got VI equals naught, which makes an angle of 30 degrees the horizontal. When the ball is released, it falls to the ground, and the trolley moves 2 meters up the slope. So it moves 2 meters up the slope, accelerating at 0.43 meters per second squared. They also say the coefficient of the kinetic friction mu k is 0.2. And it says ignore the rotation effects of the wheels and air friction. Okay, now it says draw a labeled free body diagram showing all the forces acting on the trolley as it moves up the slope. So we want a free body diagram, so we want a colored in circle. In grade 12, as I said before, I like to actually draw a little dotted line to represent my slope just to make my life a little bit easier. So do you agree there is going to be the force of gravity straight down? There is always a normal, F normal, which is perpendicular to the slope. Then, do you agree that there is going to be T pulling it up, and then there has to be the force of friction? Now, a couple of things. First of all, you need to draw this F normal so it looks kind of perpendicular to the surface, which is why I draw the horizontal end. Secondly, since we know it's going accelerating, your T has to be longer than the force of friction. And thirdly, here's the trick. This is for 4 marks, 1, 2, 3, 4. 99.999% of the time, if they're giving you 4 marks, it means that they want you to draw 4 forces, So that's the way it works. Now it says, show the friction force of 6.79 newtons acts on the trolley as it moves up the slope. So we know that the force of friction is mu k Fn, but Fn is equal to the perpendicular component of the force of gravity. So I'm going to change color. So we know that this makes a little triangle here, where this is Fg perpendicular and this is Fg parallel. So in other words, the force of gravity is doing two things. The one is it's pulling the object down into the earth, and the other is pulling it down the slope. But these two are equal. So if I work out what Fg perpendicular is, then I will know what F normal is. And we know the angle of the slope is 30 degrees. Therefore, we know that this angle here is 30, and that is 90. Because these are the vertical and horizontal components of the force of gravity. So we want Fg perpendicular, which is the adjacent side, and we know the mass of the object, so we have the hypotenuse, which is the force of gravity. So we can say that Fg perpendicular is equal to, or better way of doing it, is Fg cos 30 degrees. Sorry, I was hesitating because I thought maybe I should tell you that cos 30 degrees is equal to Fg over, it's going to be adjacent over hypotenuse, it's Fg over Fg. And then you could rearrange it and you get this answer here. But that there is the same as the normal force. So therefore the force of friction is going to be 0.2 times by Fg, but that is the weight, which is going to be 4 kgs times 9.8 cos 30 degrees. So we're going to pop this in our calculator, and we go 0.2 times 4 times 9.8 times cos of 30 close bracket equals 6,7896. And they've asked us to prove that it's 6.79, and if you round off to 2 decimal places, you get 6.79. So yay, that's 6,79 newtons, and we have our little 3 marks there. Now grade 12s. The reason they've asked you to prove that it's 6.79 newtons is because they want you to use this in the next question, or in questions further down, and they don't want you to forfeit the marks because you don't know what that frictional force is. So if you could not get 6.79 because either you didn't know it, or you didn't know how to do it, or you did it and maybe you made a silly mistake or something, you didn't get the 6.79 newtons, please use it in the following questions. Even if they're wrong, even if you know for certain that they've messed up and the correct answer is your answer, tough cookies, you use what they've given us and you put it in correctly on these questions here. Okay, please do that. Now it says state Newton's law, second law of motion in words. Okay, so I'm not going to do that. It's F net equals ma. Okay, now I will. So guys, you cannot write this F net equals ma. If you write that, you're going to get 0. You need to say that an object accelerates with an acceleration that is directly proportional to the mass and inversely proportional to the force if there is a net force acting on the object, or something to that effect. You guys need to go study it properly. Okay, so what are they hinting? They're hinting that we're going to use F net in the next question, which says calculate the tension in the string. Okay, so we know that the net force is always equal to the sum of all the forces acting on an object in the same plane, which in this case is going to be tension plus the force of friction plus the force of gravity parallel. There are 3 forces acting on this object as it goes up the slope. It is the force of gravity parallel, that's that component of the force of gravity, the force of friction, and tension. And you will notice that I've just done pluses here because remember that the net force is equal to the sum of all the forces. Now I want to look at things like direction. So I'm going to choose up the slope as positive. Okay, therefore it's going to be T minus the force of friction minus Fg parallel is going to be F net. So what do they tell us? They tell us that this accelerates up the slope at 0.43 and it's got a mass of 4, so we can get F net. We want tension. They've given us force of friction, so all we have to do is calculate Fg parallel. So Fg parallel, do you see that the angle is 30 degrees? This is the opposite side to the force of gravity, so therefore using SOHCAHTOA, we want the opposite side. We've got the hypotenuse, so we're going to use sine. So we can just say that sine of 30 degrees equals the opposite side, which is Fg parallel over Fg. Therefore, Fg parallel is going to be Fg sine 30 degrees, right? So now let's do it. So we've got F net, which is the mass of this, which is 4, and we know it's accelerating at 0.43, equals the tension in the string minus the force of friction, which they gave us, which is 6,79 minus Fg sine 30 degrees. Now I'm taking it slowly so you can see what I'm doing. So we can pop this in a calculator, we can just multiply it in our heads. 4 times 3 is 12, carry 1, 4 4 is 16, that's 17, 1,72, plus 6,79, I'm just taking that across, equals T minus, now Fg, we know the mass is 4, we know that gravity is 9,8, and then it's just sine 30 degrees. So if we add this up, 9 and 2 is 11, carry 1, 7 7 is 14, is 15, carry 1, that becomes 8,51 plus, so now we just have to put this in a calculator, so let's do that. So it is 4 times 9.8 times sine of 30, close bracket, equals which is 19.6. That's 19,6 equals the tension. So again, that's going to be 1, 6 and 5 is 11, carry 1. 19 and 8 is 27, so it's 28 newtons is the tension in the string. So this is going to be 28,11 newtons. Cool, and that is the tension in the string. Now it says calculate the speed with which 3 kilogram ball strikes the ground. Okay, so what you need to realize is that if this trolley is accelerating up the slope at 0.43 meters per second squared, that this ball must also be accelerating towards the ground at 0.43 meters per second squared, because they are joined. Okay, they are joined. Therefore, we know the initial velocity is 0, the acceleration is 0.43, the delta x is 2 meters, and we want the final velocity Vf. So we can use the equations of motion. Vf squared is equal to Vi squared plus 2a delta x, which is going to be 0 plus 2 times 0.43 times by 2. So we can pop that in our calculator, and we can just go 4 times 0.43, and that becomes 1,72. And then we have to square root that answer, and the answer is 1,31. So the final velocity is 1,31 meters per second, and we don't have to give a direction because they asked for speed. So the trick with that question was to realize that it wasn't accelerating towards the ground with acceleration due to gravity of 9.8, but because it had it was dragging the trolley behind it, it was accelerating with the same acceleration as the trolley, which was 0.43 meters per second squared. Right, grade 12, nice tricky question. It had forces, it had friction, it had Newton's second law, it had free body diagrams, it had everything, including equations of motion. So please, grade 12s, make sure you can do all these aspects. And if you didn't understand what we were doing here, go through those sections again and then come back and try this question again. And remember what I said to you, the best way to do these questions is to stop the video when you see the question and then try the question for yourself, and then let the video play on once you've tried the question to see if you get the right answers. Have a great day.